The broadcast is now starting. All attendees are in listen-only mode.
Okay, good morning, guys. You guys in the classroom? Can you confirm you can see me in the classroom? Okay, perfect. Thank you, Yusuf. I'm going to give you guys a couple of exam questions while we're waiting for a few more people to log in. So here would be a sample type of exam question, okay? If you can just fill that out for me. Just wait a couple more seconds. Close poll. Share results. So, what system of medicine develops the four humors? And the answer is Greco-Roman medicine. And I'm just going to double check. I got a text from Marilyn, who I think. Okay, she just let me know things are working. So that could be a sample exam question from the intro. What system of medicine developed the three humors, or what system of medicine uses describes the three doshas, or what is the traditional medicine from South Asia and India? What will be the traditional medicine in Japan? A couple questions like that. How about I give you a couple more of these? Just a second, I forget how to do this. Oops, didn't mean to do that. Hide results. Okay. I'll do this one quick. Which is the following people is the father of modern medicine and developed humoral theory? I'm going to give you guys like 15 more seconds. You know what? I lied. That's good enough. Share results. Hippocrates. So Galen actually rejected a lot of what Hippocrates and some of the earlier, Galen further developed the humoral thing. Paracelsus rejected a lot of it. Let's do another couple. Kempo is a traditional medical system, of what region? So say I'll give you like 20 seconds. Or until I get like 50% of people voted. Share results. You guys know it. Japan is the one for that. Let's do a couple more of these. Okay. A little trickier, see if you can remember this. Which of the following compounds, pardon the typos, I did this quickly this morning, is used in herbal medicine and is found naturally occurring in plants? So I'm going to give you a minute for that. I'm going to grab my cup of tea. 1 second. Okay, 72% of people voted. Let's close the poll and share the results. So, this is a little trickier, but you guys did pretty good. So, Taxol is naturally occurring, but it was never used in herbal medicine. It originally came from the Pacific yew, and the Pacific yew is never used for cancer. They found it just by screening plants. Tamiflu is a drug synthesized from shikimic acid, which is a precursor you can get from various plants, including star anise. Digoxin is the right answer. It was used in herbal medicine, and you can isolate it from plants. And then acetylsalicylic acid, that is aspirin, and it's been modified from the salicylic acid that can be obtained from willow bark and a number of other trees. So both acetylsalicylic acid and salicylic acid are anti-inflammatories, but the modification just changes some of the properties. So there's that question. Let's try another one. So here's a phytochemical question. Diterpene lactones are synthesized from how many isoprene units? Select the answer, 1, 2, 4, or 20. And you got to remember how many isoprene units do monoterpenes have, diterpenes? The other type of question I could ask is how many carbons do most diterpene lactones have, or sesquiterpenes or tetraterpenes? So it could be carbons or isoprenes would work. We got about 70% of people voted. Share results. So diterpenes are made from 4 isoprene units. So if you remember, a monoterpene is made from 2 isoprenes, has 10 carbons. Sesqua is made from 3 isoprenes. Diterpenes are made from 4 isoprenes, and then keep going up from there. So most of you guys got that one right. And there's an exam question like this in the pool, whether it's diterpenes or monoterpene lactones or triterpenes. It would be like this, either carbon related or isoprene related. Here's another question. If you collect the sap from a Christmas tree and heat it up for days at 20 degrees Celsius, the remaining substance is called... What do you guys think? Got some people who answered it right off the bat got it right. And then we have some people changing their mind. Probably a couple people guessing. That's enough. Share results. So the resin or the sap from the tree would contain both essential oils and rosin. It would not contain latex because latex is water-based. If you were to evaporate it at 200 degrees Celsius, even if it was a latex, you would evaporate off all the water and some of the other components, and it would be different. Essential oils would just disappear into the atmosphere, so that would not be the answer. If you collected what evaporates off, then you'd have the essential oils. The rosin is the remaining substance. Okay, so most of you guys got that right. Let me see if I have anything else. Here's a question. This will not be on the exam. So my question is, how many local on-campus lectures would you like to have? So far you haven't had any, and I'm wondering if I should plan to have one right after the midterm. We could do one on campus. And I'm just curious what you guys want. So these are the ones on campus, not the remote ones. So these would be live in person. Okay. See if I can get a couple more people to vote. So the majority of people would like 2 in-class lectures. Some people want none, some people would like 1. So I would say about 70% of people want basically 2 or less. A couple people want 3 to 4. Some people want to have all the lectures on campus. It's a little different. Last term, majority of people wanted 0, 1, or 2. Didn't really have anyone who wanted 5 or more, but larger group. So we'll see. Maybe what we'll do is we'll plan let me check the schedule, check the weather, and maybe we'll see if we can do one after the midterm. Okay. So let's get started on uh, someone said not the Monday after midterms. I'm not sure why, not the Monday after midterms, but anyways. Okay. Can you guys see my screen? Had results. Okay, can you see? Let's get rid of me. We don't need to look at me. Okay, phenolics and related. Can you guys see that slide? Sometimes it gets hooked up when I go back and forth. You guys out there? Can you hear me? Can you see me? Hello? Okay, this sometimes happens. Let me see if I can figure this out. How do I get rid of it? Share polls. Okay. Poll close, manage polls. How do I get out of this? Okay. Let's do find results. Okay, can you see my screen again? Polls. Manage polls. I don't know why I get hooked up and sometimes I can hear you. We can see the quick poll. What if I do this? Did that change anything? That did not change anything. Okay, how do I get out of this poll? So some kind of glitch with their thing. Sharing, showing paused main screen. I don't want to pause the main screen. There. Does that work? Yep. Okay, I figured out how to do it. Okay, so is that exam review little questions helpful for you? Because if it is, I'll make a list of exam type questions for you. My plan is to try to get through everything. If I'm feeling rushed and I'm not going to cover all the material, I'll record whatever's remaining, and then you can watch the remaining stuff if you need to for the exam. the midterm, if we finish all the phytochemical stuff before the midterm, it'll make the midterm a little heavier in like the material is just a little bit more dense. And then the final exam will be a little bit lighter. So I think I'd like to try to get through the stuff that way. You'll find the final a little bit easier to study for. Okay. Somebody would like me to do those questions every class. I'll see if I can do that. The challenge begins, or the issue with that is sometimes I start running out of time, but I'll see if I can do that. Okay, so phenolics and related. We've talked about, last time we were talking about the terpenoids and the different types of terpenoids, and many of the terpenoids have antioxidant properties for sure. Certainly the carotenoids do. And when it comes to the phenolic compounds, this is a huge class of compounds, and a lot of the generalizations we can make for many of these classes is the great antioxidants. That's probably the most significant thing you can say about the phenolics. And many of them also have anti-inflammatory properties and anti-cancer properties as well. There are different classes of it, and they're kind of hard to group together sometimes. So I put the umbrella for phenolic and related, mainly because they're synthesized by similar type of pathway. Now I've got a little PDF file I can upload. Some of these slides don't show up very well in your note package just because it was a screenshot. And then when it was optimized, otherwise it'd be like 40 megabytes. When it was optimized, you sort of lost some of the detail. But this is sort of a quick little summary of how the various phenolic compounds are made in this pathway. And what we'll talk about is what the simplest forms of the phenolic compounds are first. So what is a phenolic compound? Well, a phenolic compound contains phenol. And phenol, from a chemistry standpoint, is an aromatic ring. And what that means, you've got those double bonds, space, double bonds, space on a six-membered ring, okay? And what actually happens from a chemical standpoint is those double bonds are whirling around. It's like an atmosphere around that circle. So they're spinning around, and the conjugated bond allows them to bounce around, sort of move around easily. And by doing that, it can stabilize single electrons. And so that OH group that hangs out there, it can actually grab an electron from somewhere, a single electron, like a free radical, and basically sequester that free radical, that single electron, onto the ring structure, and thereby stabilizing it. And then they can give it up later on. So it's a reversible process where they can accept and donate electrons. And that's what's unique with phenolics. Now, just as an aside with the carotenoids, it too has conjugated double bonds, but it's not in a ring structure. And when you add free radicals to a carotenoid, it tends to destroy the structure and bleach it. So they don't tend to be reversible like the phenolics are. So that's one thing. So phenol or phenolic compounds have an aromatic ring with an OH group attached to it. Most of these phenolic compounds are also derived from what are called phenylpropanoids. And we'll talk about that more in a second. So it's basically, many of them have this precursor that's used to make the different types of phenolic compounds. Now, phenolic compounds that you've heard of include things like bioflavonoids, anthocyanidins, curcuminoids, things like that. So with regards to the simplest forms of the phenol compounds, you can have basically basic phenol, which will rarely exist in nature for more than a few seconds because it'll evaporate off. It won't really be found in the plant, but that basic structure will be found with other types of compounds. There's also something called catechol, which is a phenolic compound that has two OH groups on it. Now, you may have heard of catecholamines, just as an aside. These are neurologically active compounds like epinephrine, norepinephrine, and dopamine have the catechol backbone. So even those types of compounds will have some anti-inflammatory or antioxidant effects to them. But more importantly, they have very strong neurological effects because of the presence of the nitrogen on them. So that's the catechol group, and we'll talk about that more when we discuss some of the phenolic compounds. And then finally, we have a hydroquinone group. And this hydroquinone group at the bottom, you know what? I just noticed a typo. Let's see if I can. Rats, I can't get in there. If you can just fix this on your slide for me. I hate when I find hydroquinone. I just hide that over there. Perfect. This hydroquinone group is found in certain plants, but usually as a glycoside. Well, I'll give you some examples. So phenolic compounds in general, things like the bioflavonoids and some of these other antioxidants, when you consume a diet rich in these compounds, they tend to help prevent degenerative disease. Okay, so degenerative disease would be things like atherosclerosis, also just things like Alzheimer's can be thrown into that category. Anything where you have a lot of inflammation and oxidative stress that causes damage to the structures in the body, a diet rich in phenolics will help with that. Also, many of these have anti-cancer effects by interacting with certain receptors on cancer cells, but they also have an anti-inflammatory effect, which indirectly can also benefit things like cancer. With cardiovascular disease, some of these guys can reduce oxidative stress to help reduce the formation of plaques in the arteries. Some of them will also have blood pressure lowering effects. I think that's many of them will modulate adrenergic receptors in the body to have a blood pressure lowering effect. Some of them, because of their anti-inflammatory effects, can help with arthritis, just to decrease the inflammation. And also a number of these compounds will have some antimicrobial effects to help fight off infections. So these compounds are ubiquitous in nature, meaning they're found in all sorts of different plants, but there are certain plants that have higher amounts in it. And when you consume a diet that's rich in fruits and vegetables, you will be consuming lots of phenolic compounds. And there was one study that I saw that showed people consuming a antioxidant-rich diet that was high in phenolic compounds had basically, I think it was like a 70% risk reduction in getting some kind of cardiovascular event, some kind of like a heart attack. And so the Mediterranean diet usually gives you about a 30% reduction. But if you can take something like the Mediterranean diet and then add some really good antioxidant-rich fruits and vegetables to it, you can get an even better outcome. And the way that these guys work for the most part is that they have this ability to accept and donate electrons. Now, as an aside, antioxidants usually decrease oxidative stress in the body, but appreciate that there are a number of studies showing that high amounts of certain antioxidants, when given alone, like vitamin E or what other ones? Vitamin E is one of the big ones, but I think it would apply to most of these antioxidants, that you can actually increase oxidative stress if you take too much of a single one. And if you take lots of a whole bunch of different ones, I think you tend to have a protective effect that decreases oxidative stress. So there is concern with supplementing with mega high amounts with a single one could have negative effects. It may cause more harm than good. This just shows a little diagram of some of the simple phenolics. These ones don't really have a whole lot on them except for maybe an extra OH group, and some of them might have a glycoside like arbutin. And arbutin, this is a herb or a compound found in a herb called bearberry. It's also found in another couple of related herbs to bearberry. Pipsawana is another one that you can find in the mountains. It's a cousin of bearberry, and it's in the mountains of Alberta and BC. It's certainly used in herbal medicine for the same indications, but it's not as widely used or available. Bearberry, the herb, it's primarily used as a urinary astringent. and also a urinary antiseptic. Okay, let me just write down. I'm going to add this to your list. Antiseptic. I've kind of said it by stating it's an antimicrobial, but that'll just, some people will use the term urinary antiseptic. So the way that this guy works is you can find the compound arbutin in it, and what this is the purple thing is a hydroquinone, and there's a sugar attached. When you attach a sugar to this compound, it makes it relatively safe and stable because with that one OH group occupied on the hydroquinone molecule, it can't readily accept and donate electrons. It kind of like affects its reactivity. But with the process of a hydrolysis, where you can add, let's say, stomach acid, or if there's a bacteria or some other organism that contains an enzyme called beta glucoxidase, what will happen is the phenolic group there, the hydroquinone, gets liberated and to give you hydroquinone. And then this hydroquinone molecule can accept and donate electrons, and in the process can generate free radicals. And it can actually have a bleaching effect. So hydroquinone, the molecule itself, can basically have a bleaching effect, and it's been used topically to whiten skin in some people. Now, in the case of bearberry, the way it works as a urinary antiseptic is when you consume the bearberry, the arbutin goes into your body. Some of it gets hydrolyzed in your stomach by the stomach acid, releasing some hydroquinone, which could have some local effects there. It could also have some negative effects. For example, long-term use of high amounts of arbutin in animals have shown that it slightly increases the risk of stomach cancer. So I wouldn't necessarily want to use something like bearberry preventatively every single day for urinary tract infections. I'd be more inclined to use something like cranberry juice, which would have other health benefits and not have this risk. But so when you consume the arbutin, this molecule travels through the body and ends up in the urinary tract eventually. And when certain bacteria like E. coli come across the arbutin, what they see here is a food source. The sugar molecule is a good energy source for them. So they'll be happy to see that, and they'll basically use their enzyme beta glucoxidase to cleave off the sugar molecule so they can eat it. But in the process, they liberate the hydroquinone, which then basically will attack it. And the hydroquinone molecule, in addition to causing free radical damage, because it's such a small compound and it's amphiphilic, so you have the water and the fat-soluble components, it tends to diffuse across cell membranes and disrupt them. So you get free radical damage and you have a disruption of the cell membrane, which weakens the bacteria and sort of helps to inhibit their growth. So the arbutin, the way I look at it, it's kind of like a mousetrap. It's like you've got the cheese or the peanut butter, whatever you use in your mousetraps, which is the sugar, the glucose, and then the actual trap itself is the hydroquinone molecule that is baited with the sugar. Okay, does that make sense to you guys? What is ubiquitous? Ubiquitous just means found everywhere. So it's widespread, found everywhere. It's just a fancy word. So those are the simplest phenolics. So the hydroquinone molecule is the only real one we use in herbal medicine, and it usually exists as a glycoside. Okay. Now there's some other things like phenolic acids that we'll talk about. I don't know why I thought I had some pictures here. So phenolic acids, these are substances where you have a phenolic group with a carboxylic acid attached to it. Okay. So if you look at, for example, salicylic acid, let me go back up there. Oops. So if you look at the salicylic acid, let me just show you. This, in case you don't know, is your That's your carboxylic acid right here, okay? And this is why it's called a phenolic acid, because you have a carboxylic acid and it's attached to a phenol, okay? So you find these types of compounds widespread. You can have salicylic acid, you can have other things called like methyl salicylic acid, which is what wintergreen is. Wintergreen has that minty-like smell that's found in some sport creams, like 8535 has it. You also find it in some chewing gum. It has an anti-inflammatory and also an antiseptic effect. And you can also find these in other compounds like gallic acid. And gallic acid is a type of tannin. And so these tannins basically have an astringent property. So if you eat take black tea, for example, if you took a tea bag and started sucking on it, your mouth would pucker up like black tea. And that would basically be because of the gallic acid type of compounds basically interacting with the proteins on your tongue. So that's one example. Gallic acid has anti-inflammatory effects. It has astringent effects. Other things like salicylic acid, as you know, like aspirin, has decreases fever. That's an antipyretic effect. So pyro meaning fire, so anti meaning reducing fire or heat. And then it has that strong anti-inflammatory effect, which is why it was used historically for fevers and for arthritis and other inflammatory conditions. Just as an aside, benzoic acid, which sometimes is called a phenolic acid, but that would be inaccurate because it doesn't actually have that OH group on it. This is a common preservative found in the food industry. When I was a kid, there would be these plastic cups of orange juice with a tinfoil lid, and it had a very unique sort of tangy taste to it, but not like in a good way, like in a synthetic sort of way. And that's the benzoic acid. It's used as a preservative because most of these simple phenolics, or these phenolic acids and simple phenolics, have an antiseptic or an antifungal effect, so they can be used as a preservative. You will find them when you're eating fruits and vegetables in general. Benzoic acid does exist in a number of different fruits and vegetables as well. So those are what phenolic acids are. Now, there's a couple of variations of this. We'll talk more about gallic acid later on when we talk about tannins, hydrolyzable tannins. So this stuff will come up later on. Ellagic acid is made from the fusion of two gallic acids. Now, what gallic acid is, let me just show you. So if you look at this picture here, so we've got, oops, what I've highlighted there is a gallic acid molecule. You've got a phenolic compound, and the gallic acid has 3 OH groups on it, and then you have this carboxylic acid group. And this is what makes up a lot of the tannins in fruits and vegetables. Now, ellagic acid is very similar. It happens to be a dimer, like basically two of these gallic acid molecules stuck together. And it's often also found in things called hydrolyzable tannins that we'll get to later on. And so you'll find various forms of ellagic acid. It could be glycosides, where you might add a couple sugars onto this. You'll find these in things like raspberries and also in other things like pomegranates, for example. And so there's an astringency associated with berries that sometimes is associated with this ellagic acid molecule. And we know that these compounds do have antioxidant, anti-cancer, and astringent effects associated with it. When you eat something like pomegranates or raspberries, the red color is not associated with the ellagic acid. It's associated more with the anthocyanidins that we'll talk about later on. But some of the astringency is associated with these guys, and there are health benefits to it. So somebody asked a good question. If hydroquinone is a phenolic compound and is an antioxidant, why does it create free radicals? Does it create both free radicals and also act as an antioxidant? So one thing about antioxidants, I'll just emphasize again, is that every single antioxidant will act both as an antioxidant and a pro-oxidant. And what I mean by that is it will attack, it will grab free radicals that are floating around in the body. But what antioxidants can also do is if they come across certain structures like uh, certain conjugated double bonds, omega-3 fatty acids, things like that, those double bonds are relatively unstable. And so although you might have two electrons that are paired, happily paired on it, you could persuade them to break up and generate a free radical. And so those single electrons, it's kind of like you can go in, if someone's married or in a serious relationship, it doesn't mean they're going to stay in that relationship. If you're persuasive enough, you could probably get in there and break up the relationship there. Some of them are stronger than other relationships, but so it's much easier to hook up with a single electron, just like it's easier to hook up with a single person than it is for one that's married, but it's still possible. And so that destructive pro-oxidant effect is like going in there and breaking up a marriage. So if you have enough, basically antioxidants, really high amounts of antioxidants or pro-oxidants floating around in the body, they will generate free radicals rather than basically sequester free radicals, if that makes sense. It just depends on how tempting it is, right? So this is why there is concern by a lot of the scientific community that high dose supplementation with antioxidants could be damaging. When you look at, for example, a lot of the reductionistic sort of thinking, and naturopaths and nutritionists and research can all sometimes share this, where you're looking at it and going, oh, it appears that here's a fruit and vegetable that's really good for you. So let's try to isolate what that really fantastic phytochemical is and then supplement it and see if we can get the same benefits. And it's rare that supplementation with a single compound is going to give you the same benefits as eating a diet that's rich in fruits and vegetables. And the analogy that I like to give people is it's kind of like if you have a soccer team or a football team, let's say football because of the Super Bowl yesterday, you might have a really good football team and you try to analyze who's responsible for the success of that team. It's not going to be just, the quarterback. The quarterback might be important, really important, but if you were to take the quarterback and make a team full of all the best quarterbacks in the NFL, chances are that team wouldn't do very well because they have a very precise role to play, but they may not be a very good defenseman. They may not be, have all the other positions that they need. They're not going to be covered. You're only good at one particular role. And antioxidants are a little bit like that, where it's good to have some vitamin E, some vitamin C, some phenolic compounds, some proanthocyanidins, some NAC. All these different compounds will work as a team, catching and sort of moving electrons around to try to keep them sequestered. And you could actually cause more harm by getting a whole bunch of, the same antioxidant, just like getting the same player on the team in high amounts at the expense of the other ones could be damaging. Okay, does that make sense to you? I don't know if my analogies are helpful or if they're kind of just stupid. And the other thing is, for example, some of these compounds are good in small amounts, and then when you increase the amounts, it becomes toxic. So for example, gallic acid and ellagic acid, very small amounts might work synergistically with some of the other things in your diet. They may have some antioxidant effects and a number of other things. We do know that high amounts of gallic acid can be very damaging to the kidneys and to the liver. And so if you had an open wound and you poured a whole bunch of, let's say, oak bark on it, it could actually cause more harm than good. I mean, it can help close up the wound, but if you absorb a lot of the gallic acid, it can be have a negative effect. Think about if you're consuming red wine, a really, really oaky red wine on an empty stomach. That too could go and give you stomach aches because of the tannins in that will start interacting with the proteins in the stomach. And so we'll talk about tannins more later on. So again, these things are good for you in small amounts as part of your diet, but isolating and taking high amounts may only be appropriate for treating certain conditions and not necessarily health promoting in general. I would say, someone asked, what happens if you eat many different foods high in antioxidants? Will the same thing occur? When you look at diets that are rich in antioxidants, um, and when you have a variety of things, including chocolate and tea and fruits and berries and various vegetables, herbal teas, little wine, all those things are good for you. And I think it's very hard to get into the toxic ranges by eating a diet rich in antioxidants. Like certainly all the research shows that eating a diet rich in antioxidants is good for you. Now you would be cautious about eating purely a diet that's full of fruits only, just because of the sugar content could be damaging to you. But that wouldn't be a negative effect of the antioxidants. In general, antioxidants usually have a protective role even against diabetes. So although, let's say, honey is rich in sugar, it does have a lot of phenolic compounds that we haven't gotten to yet, but the various flavonoids. The flavonoids have anti-diabetic effects, so it helps to counteract the negative effects of some of the sugar in the honey or other fruits and vegetables. But if you consume too many fruits and vegetables, and if you're eating too much honey, you're definitely going to get diabetes. So small amounts is good, large amounts is bad. Eating a healthy, balanced diet, I'm not really concerned about that though. So the next thing we're going to talk about are phenylpropanoids. So there's a couple of amino acids, phenylalanine and tyrosine are amino acids in the body. And they can basically be used to make things called phenylpropanoids. And phenylpropanoids are the building blocks for all these various compounds showing on the right here. Various things like coumarins, phenylpropines, polyphenols, flavonoids, etc., etc. And we'll talk about these all today, hopefully. So phenylpropanoids are the building blocks. As I mentioned, they are derived from phenylalanine and tyrosine. So those are the two amino acids that can make these phenylpropanoids. Now, phenyl or phenyl group is the aromatic ring there. So if you have propane in chemistry means 3 carbons. So propane gas is a 3-carbon gas. Phenylpropanoids means you have a phenyl group and some kind of propanoid or 3-carbon chain attached to it. Okay. So to start off with phenylpropines, these are very important compounds. We've already talked about monoterpenes, and monoterpenes are very similar in structure and function as the phenylpropines. They're basically small hydrocarbons. They usually have about, let's say, 9 carbons, generally speaking. Monoterpenes generally have 10 carbons. There can be variations on that. Like if you look at the anethol molecule at the bottom left, that compound there is one of the essential oils that you'll find in like anise and fennel. It has like a licorice-like smell to it. That compound actually has 10 carbons, if you count it up, 6 on the ring, 3 on the propene chain on the left, and then there's an extra carbon thrown onto the oxygen. But that one was added on later on. So originally it would have only had the 9 carbons, and then the methyl group was added later on. So most of these will have 9 carbons on the main, like attached to the main ring structure directly. These are made from the basically phenylalanine or tyrosine molecules. They're small, they're volatile, so they're going to be primarily found in essential oils because something that's this small will easily evaporate. And generally speaking, the boiling point of these would be around 300 degrees Celsius, plus or minus 50 degrees. And from a herbal standpoint, the main actions associated with these guys are going to be things like a carminative action. So as we mentioned before, it increases blood flow to the mucous membranes or if you apply it topically, it can cause the capillaries to dilate. Many of these guys also have antimicrobial effects. So generally speaking, essential oils are usually made up of monoterpenes or sesquiterpenes and also phenylpropenes. Now, the phenylpropene, the reason why it has that name is the phenyl group is like the phenolic compound, a little six-membered ring there, which is phenyl. And then you have the propene, which is propane would be 3 carbons attached to it. But this case, it has 3 carbons with a double bond in there, and that double bond gives it the ene. So phenylpropene is because of the phenyl group plus the propene, which is unsaturated side chain there. So phenylpropenes are going to be rich in a number of the spices you have in your kitchen. So anise and fennel, you can eat the seeds that are rich in it. Also the vegetable itself, if you roast it up, has a nice small amount of the aromatic oils and a just nice pleasant sort of smell to it. Clove is rich in these compounds as well. Basil, cinnamon, tarragon, cumin, nutmeg, sassafras as well, but you probably don't really know sassafras. One thing that's worth mentioning is that although these phenylpropenes are generally pretty good to eat, high amounts of certain ones have been linked to liver cancer and liver problems. And the reason for this is that depending on the location of that double bond on that phenylpropene or on the propene side, I think what happens is that when it goes through the liver and it's metabolized, it can actually become a reactive intermediate, which is basically a toxic substance. When you look at these various phenylpropenes here, cinnamaldehyde is found in cinnamon oil. It's one of the things that gives cinnamon its nice distinctive odor. Anethol is found in anise. Estragol is found in basil. So both Thai and Italian basil has that sort of smell to it. Now, eugenol, safrole, and myristicin, as well as estragol to some degree, if you look at the placement of that double bond, it's right at the end of the side chain there. So this spot right here, I don't know if you can see my cursor or not, when it's stuck on the end there, the pattern that I've observed is that those compounds seem to be more hepatotoxic. And we know that safrole, for example, was once used to make root beer. Now, root beer now uses other flavorings in it, but the safrole came from a tree called sassafras. And safrole, the problem is that if you're consuming high amounts of it, you would start developing acute liver problems, and chronically you'd end up developing liver cancer. Now, we know that clove and nutmeg also, at least in vivo studies, and have shown that it does have hepatotoxic effects. So you have to be careful about consuming a lot of this in your diet. Now, appreciate the fact that when you're consuming things like basil, basil has a number of other phytochemicals that have antioxidants and health benefits. So I'm not really concerned about someone consuming, let's say, basil on their spaghetti. But if you were taking, let's say, high amounts of clove for long periods of time to fight off, let's say, candida in the gut or some other type of infection, it is possible that it could be damaging for the liver, and you just kind of want to be careful about that. So phenylpropenes, for the most part, are pretty safe, but like any essential oils, high amounts of essential oils in general, you have to be cautious with, and there's some that you have to be even more cautious with, including the safrole, eugenol, and myristicin. In the old days, you used to use clove oil all the time topically for toothaches and stuff like that. Carrie's asking, is holy basil one that can be toxic to the liver? I think if you're drinking holy basil tea or taking it as a supplement, the relative amounts of these things is going to be pretty low, so it should not be an issue. Just like I think those phenylpropenes we describe are probably toxic to the liver in a similar fashion that Tylenol is toxic. Tylenol is the #1 cause of liver transplants in North America, and most people aren't aware of that. Now, it's extremely safe if you keep the dose within the therapeutic range, at least for most people. We'll talk about that later on. But when you exceed that, it becomes toxic. So these guys are relatively safe in small amounts, which is probably going to be what you're going to get from having a couple cups of holy basil tea, or adding a little basil to your pesto, and or eating pesto with your pasta and stuff like that. I think the benefits of drinking those things and consuming them outweighs any sort of risk from those compounds. But if you were to take the essential oils in isolated amounts, and let's say consume 10 milliliters of the essential oil from holy basil, or from clove, or from sassafras, I think under those circumstances it would become toxic. But I think holy basil tea is good. Holy basil also has other compounds like ursolic acid, which Carrie mentioned, which is totally true. And the cool thing about the ursolic acid is that it may have some hepatoprotective effects. So again, when you consume a plant or a fruit or a vegetable, there's not one compound, there's a team of compounds in there that have really great health properties. Now, sassafras also probably has a team of compounds, but it just happens to have more of the bad members than the good members. Just because it's a plant doesn't mean it's safe, but most of these things like holy basil, oregano, things like that, people consume enough of them. We have a pretty good idea what's safe and what's not. Now, there's a specific group of phenylpropanoid derivatives called hydroxycinnamic acids. And you will find these various compounds in lots of fruits and vegetables. And many of the antioxidant effects associated with plants are these compounds or derivatives of them. The main types of hydroxycinnamic acids include caffeic acid, ferulic acid, and coumaric acid. Now, what makes some hydroxycinnamic acids is basically you have the phenylpropanoid with the carboxylic acid at the very terminal end of that, okay? And so if you look at caffeic acid, for example, you've got that little double bond to the O, double bond to the OH. That's what the carboxylic acid is. And so these compounds, you have the phenol group on the one side, and then the carboxylic acid on the other side. So these would be fairly water-soluble compounds because there's a high percentage of oxygens relative to the carbons. And so these will be found in an aqueous solution for sure. They're not going to be as water-soluble as things like sugar or certain types of fiber, but they certainly will be. And these phenolic compounds, in general, like most antioxidants that are phenolic-based, will have antioxidant properties. Many of these will have some modulating effect on certain enzymes like cyclooxygenase to have an anti-inflammatory effects. They probably will interact with certain receptors and have an anti-cancer effect. They'll balance blood sugar and have an anti-diabetic effect. So these guys are good. Now, there are some compounds that are also good. Coffee will have a lot of these guys. I can't remember where there it is. We'll go to that in a second. So here's a phenylalanine compound or your tyrosine compound, and they remove the nitrogens, they meaning the plants. When you remove the nitrogens, you can make basically the coumaric acid, the caffeic acid, and the ferulic acid fairly easily. And all these guys have antioxidant effects. Even tyrosine has antioxidant properties associated with it. Now, there's a compound called chlorogenic acid, and this is basically a caffeic acid molecule with the quinic acid compound attached to it. Now, let me see, why is this all? Let's bring that down. So, I'm a big fan of coffee, and a lot of people are saying, oh, I'm trying to quit drinking coffee, and I don't know why there's this perception for it for a lot of the public that coffee is bad for you, because coffee is probably the top dietary antioxidant in a Western diet. And I want to convince you that coffee is really, really good for you for a number of reasons. Like, people should be drinking more coffee. Now, caffeine makes people a little edgy and can affect sleep and can make people feel stressed out, anxious, and all that. So drinking a lot of caffeine, if you're not used to it, is not good for you. Whether that's from tea or from coffee or from any kind of beverage, you don't want to overdo the stimulant. So if you want to get the health benefits of coffee, but you're sensitive to the caffeine, you can always drink decaf, and there's a lot of good benefits of that as well. Most of the antioxidants in coffee is related to basically these compounds called the caffeoquinic acids. Okay, and this would be things like chlorogenic acid or 4-caffeoquinic acid. A bit of a mouthful for me. So basically, it's chlorogenic acid with or kind of some kind of variation of that with with that quinic acid attached to it. So caffeic acid is also found in coffee, but this compound with that quinic acid on it is sort of not necessarily unique, but it's found in high amounts in coffee. Now, some great benefits of drinking coffee is these compounds help to balance blood sugar, and it has a blood sugar lowering effect, and therefore reduces the risk of developing diabetes. So, someone drinking a large Tim Hortons black coffee, that would have a lot of health benefits. Now, if you made it a triple triple, you just sort of destroyed any health benefits from it, and you've increased your risk for diabetes for sure. But the coffee itself is great for you. It's also been shown to decrease the risk of having a heart attack, having blood clots, having a stroke. It reduces the risk of getting gout, and gout is a condition that where the body produces too much uric acid. And generally speaking, gout, I think, is a response from eating certain types of foods that are either a lot of alcohol, a lot of red meat, a lot of seafood, but also if you consume a lot of fructose and sugar in your diet, it can stimulate the production of uric acid. So perhaps it's through the antioxidant effects or blood sugar balancing effects. Maybe it has a direct inhibitory effect on some of the enzymes involved with making uric acid. Regardless, there's a modest effect on gout. It's also been shown to lower the risk of having liver disease and fatty liver. So fatty liver often is a result of blood sugar dysregulation anyways in the body, but it can help protect against that. It also helps protect against cirrhosis, which is scarring of the liver. In addition, it stimulates the production of bile and the release of bile, so it can have a protective effect against, for example, gallstones. So people who consume black coffee have a lower risk of getting gallstones than people who don't drink coffee. There may be benefits for Alzheimer's disease, and there's a whole slew of different types of cancers that coffee can help reduce the risk for. Stomach, esophageal, endometrial, liver, gallbladder, prostate, skin, pancreatic. So when you look at the average American, if you're eating your meat and potatoes, if you're thinking about what a lot of people might, like a farmer might consume, bacon and eggs and toast for breakfast, meat and potatoes for lunch, and then, meat and potatoes for dinner, they're not eating a lot of antioxidants. So coffee for breakfast along with that. If you go to McDonald's and you have an Egg McMuffin or you have a Big Mac and fries and a soft drink, there's essentially no antioxidants in there. Very small amounts in the sesame seed, maybe a little bit in the green pale looking tomato that's there. But essentially, most of these fast food restaurants, the meal is totally void of antioxidants. And if you end up having an orange juice and a coffee, that might not save you, but it certainly is going to help a lot more than just consuming pop and all the other garbage. So for a lot of Americans and Canadians, coffee is the top dietary antioxidant because they just don't eat enough fruit and vegetables. Now, personally, I drink coffee. I also drink green tea. I also eat lots of berries. I eat lots of nuts and seeds. I have lots of rapini and arugula and kale and stuff like that. So for me, it's probably not necessarily the top antioxidant, but it's still significant. Let's see if I have any questions. Stephanie's asking, some people get acid reflux from coffee. Does that affect its anti-esophageal cancer or other problems? That's a great question. You'd have to look at that. Certainly, if you end up getting more gastric reflux, it can increase your risk of getting esophageal cancer. I don't know whether coffee, which does cause reflux in some people, whether the benefits of the coffee are kind of neutralized because of the reflux in those people, or if it does, even though it causes reflux, you might still have some protective effects. So, not sure. That's something you have to look up on PubMed. There's a study that showed its benefits for Alzheimer's, I think, and diabetes, but there's lots of research studies. So, we've discussed some of the simple phenolics and the phenolic acids and the phenylpropanoids and the phenylpropenes. Now we're going to talk about polyphenols. So polyphenolics are the compounds that get the most attention when it comes to an antioxidant diet. Now they may not be, a lot of the things like the caffeic acid, ferulic acid, they may exist in higher concentrations in the diet, but a lot of these guys aren't as potent in antioxidants as the polyphenols. What a polyphenol is, it's basically has two or more phenolic groups on the molecule. And so a lot of these could just be variations of some of the phenylpropanoids that we talked about already. So to give you an example, something like rosmarinic acid, and this is found in a lot of different plants like rosemary, peppermint, oregano oil, lemon balm. Rosmarinic acid is an important antioxidant in spices and plants. It may have some anti-allergic properties to it as well. It has some antioxidant effects, anti-inflammatory effects, may have some anti-cancer effects. A lot of the properties we've already described with some of the phenolic compounds already. And I think sometimes when you get the polyphenols, they seem to be a little bit more potent and have some other effects. And basically what it is two of these hydroxycinnamic acid compounds stuck together. And so over the years, you may hear about rosmarinic acid. It's found in some other plants too. Sometimes I'll use rosemary extracts for seasonal allergies along with some other things. And it may be the rosmarinic acid is the main compound. It could be something else too. That's one example. Now, some other compounds that are important polyphenols are a class of compounds called curcuminoids. Curcuminoids are the compounds that give turmeric, the spice that's found in curries, its nice yellow, bright yellow color. If you look at the picture of turmeric on the right there, that was, you can buy the fresh roots. I guess I've seen that at the grocery store now too. That was in Little India in Toronto. And when you break the roots open, they look an awful lot like ginger until you break them open, and then you see this nice bright yellow color. And it's a cousin of ginger, so they're both in the same family. And I would say the curcuminoids, primarily the main one that is researched the most is curcumin. It's probably one of the most researched polyphenols, actually probably one of the most researched phytochemicals in PubMed. If you go and type in a PubMed search for curcumin, you're going to see tens of thousands of studies, or at least thousands of studies come up for it. And it's being researched for its antioxidant, anti-inflammatory, anti-cancer, hepatoprotective, cholagogue, lots of different effects. Helps with a number of different conditions like we've already talked about. I think it's good for reducing the risk of heart disease. One thing that's really interesting when you look at India, I don't know if I mentioned this to your class or not, having been to India a couple times, it's certainly the most polluted place I've ever been to. Like it disgusts me how much pollution there is in India. And you would think that in a country like India, because of all this pollution, they should have the highest rates of cancer in the world. But the irony is that India has the lowest rates of cancer in the world. And that could be partly because a lot of them have a vegetarian diet, but that's not necessarily the case with all of them. I would say the one thing that everyone in India consumes in high amounts are spices, because the diet is rich in spices and also has a lot of plant material in it. And turmeric is the main spice found in things like curries. And so I think that consuming this in the diet um, basically has a protective effect against a number of different types of cancers. Now, unfortunately, in India, they're adopting more of a Western type of diet, so they're eating more starch, they're eating less good protein, they're eating more sugars, and that's all bad for them. And there's a lot of diabetes on the rise in South Asia, but um, the spices in their diet, and even in the teas, like if you look at chai, it's loaded with different spices. In general, if you want to be healthy, eat a plant-rich diet. You can have animal meats, but just eat lots and lots of different plants. Drink your herbal teas, drink your coffee, eat your vegetables, have some fruits, nuts and seeds. It's a really healthy diet. Now, going back to the curcuminoids, although they're similar in structure to things like ferulic acid and caffeic acid, like something happens when you stick the two of them together, a couple of these molecules together. If you look at the structure of curcumin at the bottom, there's a lot of conjugated double bonds running from the one phenolic compound. There's like one phenolic ring on one side, another phenolic ring on the other side, and then there's all these conjugated double bonds along here. Actually, I don't know if that's considered conjugated or not, but that somehow has an effect um, on the antioxidant properties of curcumin. And curcumin is a much more potent antioxidant than ferulic acid. Also, the three-dimensional structure, maybe the presence of the methyl groups on one of those OH groups, maybe that allows it to interact with certain enzymes that the ferulic acid or caffeic acid doesn't interact with as well. So I would say turmeric is definitely more potent. I would also like to say that curcumin is not the only compound in turmeric that has medicinal properties. So when you consume turmeric, appreciate the fact that in addition to getting curcumin, you're also getting other curcuminoids, so similar compounds but slightly different in structure. You would also be getting, there's one study that I read that showed that some of the polysaccharides in the root have anti-inflammatory effects that work by a different mechanism than curcumin. So it may be that when you have the whole herb, there are other anti-inflammatory properties associated with the root in addition to the curcumin, because curcumin and a lot of other phenolic compounds are not very well absorbed. And so if you eat 5 grams of curcumin powder, chances are you're only going to absorb a small percentage. And if you ate 100,000 grams of curcumin, you're not going to absorb that much more than having, 2 grams of curcumin, just because you overwhelm your body's ability to absorb it. So it may be that the whole herb, in addition to the curcuminoids, in addition to the polysaccharides, in addition to the essential oils, there could be other compounds in it that have beneficial effects. So we know that curcumin, when taken as a pill, has certain health benefits. But I'd love it if somebody did a comparative study of taking, let's say, 5 grams of curcumin versus 5 grams of turmeric powder and tested it for its health benefits for arthritis or for cancer and other things. No one's really doing this study. All the companies out there now are trying to show how their curcumin product is better absorbed and more potent than the other competitors, but no one's bothering to compare it to just plain old turmeric powder, no name brand turmeric powder from the grocery store, because there's no financial incentive. So I think sometimes the industry kind of it doesn't. It's not that they're trying to hide things; they're just trying to emphasize certain things, and so we sometimes will focus on. We'll be distracted from the truth sometimes, and so I'd be curious to know what happens with turmeric when it's supplemented compared to curcumin. That's just my opinion, though. It may be better, it may be worse, could be the same, could be different. I don't know. All I know is that when you take any phytochemical in high amounts on its own, it behaves differently than the herb. And could be better, could be worse, could be may have similar potency. It's hard to say. Someone said, I've read a lot of studies on your website that to reduce caffeine intake for does caffeine increase the rate of testosterone? Oh, that's a complicated one. caffeine has a lot of different effects on the body. And again, if you were to, um, for prostatic hyperplasia, caffeine has a number of different effects on the body. I can't remember if it has a specific role on caffeine or if it's just if you have BPH, which means enlarged prostates, you want to reduce caffeine mainly because caffeine is a diuretic, and if you have benign prostate hyperplasia, you have to urinate more. I can't remember if it has a specific effects on hormones in the body. Um, so I'm not really, I'm avoiding your answering your question because I don't know if it increases the rate of testosterone. Certainly, caffeine and some other things in coffee could affect liver metabolism of these things. I don't think it's that significant though. So it's mainly because of the diuretic effects that you avoid caffeine and men with enlarged prostates. Because if they have to pee, you don't want to give them something that makes them pee more often. Um, Another question: what is a cholagogue action? We'll talk about it more later on. Cholagogue basically means a substance that stimulates the release of bile from the gallbladder. Someone's asking, what are your thoughts on curcumin supplement rather than powder form? I've heard it's more bioavailable. Um, I think that there are different curcumin products that are more bioavailable than the curcumin you get in turmeric powder. Sometimes they'll add a phospholipid to them. Sometimes they'll put them in little micelles to be better absorbed. So it appears that it is better absorbed. But like I said, um, is it just the curcumin that we're trying to get out of the turmeric or not? I don't know. What are the differences in health benefits between gallic acid and ellagic acid? I don't know what the differences are. They're both antioxidants. They're both found in the diet. I don't think there's any studies that have looked at giving any one of them in supplementation on their own. They probably interact with some slightly different receptors, but I don't know what the difference is. Um, Stephanie's asking me, what do you think of taking curcumin with black pepper? Some say it helps with the absorption of curcumin. That's a great question. So there are animal studies that show if you combine in rats, if you take black pepper, which contains piperine, and you combine it with curcumin, that you will increase the absorption of the curcumin by about 10,000 times or something like that, which is pretty awesome. So for years, I used to tell people to take turmeric powder, add it to a little tomato juice, throw some black pepper on it to increase absorption, and you'd be good. Unfortunately, when they repeated the studies in humans, because humans have a different digestive tract and liver than rats, there appears to be no significant increase in curcumin when you take it with black pepper in basically humans. So if you're a rat, it will increase it. In humans, I'm pretty confident. Last time I checked, and I haven't checked recently, it doesn't seem to have the same benefits. So there are companies that try to sell curcumin supplements with black pepper. I think the research is misleading because you can't compare rats and humans, and unless they've done some studies in humans now that I'm unaware of, then I don't think that would be the best way to do it. You can drink decaf coffee, it's good, and it shouldn't affect the prostate. I don't think so, unless you have a sensitivity to it. So, 10:45, let's take a 10-minute break. We'll come back at 10:55. Yeah, we'll come back at 10:55 and we'll continue from there. If you have more questions, just write them down for me. Okay, you guys back? Oops, sorry. Okay, I'll turn me off, or my face, there we go. Okay, so we're still talking about the phenolics, and what we'll talk about now are probably the most significant dietary polyphenols. And these are going to be related to the flavonoids and stilbenoids to a lesser degree, but we'll start with the stilbenoids. So from the hydroxycinnamic acid, we can basically add a whole bunch of carbons onto these guys, acetyl groups, and then eventually you get a couple different types of polyphenols can come out of this. So you can either get the flavonoids or stilbenoids. The main difference between them is they're both polyphenols, so there's two OH groups. The stilbenoids have a two-carbon bridge separating them. And then if you look at the flavonoids, there you basically have a three-carbon bridge separating them. Now, you've got that little extra O ring structure there on the flavonoids that's unique to them, but essentially stilbenoids and flavonoids are pretty similar in structure. Starting with the stilbenoids, a lot of the health benefits of red wine are associated with the stilbenoids and also the anthocyanidins. The anthocyanidins give red wine that nice red, rich color to it. Resveratrol is a stilbenoid that's found primarily in grapes, but you will find it in blueberries and peanuts to some degree as well. And because it's a phenolic compound, it has a lot of antioxidant effects to it. Interesting, in scientific studies, there appears to be some anti-aging properties associated with resveratrol. Now, what's interesting about that is if you look at the research studies on extending maximum lifespan, antioxidants in general help reduce the risk of getting degenerative diseases and atherosclerosis and heart disease and cancer. So they can prevent you from dying due to some kind of disease, but they don't appear to slow down the aging process for the most part. The only thing that's ever been shown to actually extend maximum lifespan, or one of the main things that has been shown to extend maximum lifespan, is a caloric restricted diet. So we know that in animals, if you reduce the caloric intake, the number of calories they consume in a day, it appears that you can extend life from, let's say, in certain animals, if normally they die in 2 years, you might be able to extend their maximum life to 3 years. In humans, that might translate to, if you normally die at 80, you might be able to get them to over 100. And by reducing the calories, it appears to activate certain genes in the body that express things and have this effect. Now, what's fascinating is that resveratrol appears to interact with some of these genes and have a similar effect on the body as caloric restricted diet has. Now, this has been shown in animal studies or test tubes studies, in vivo studies, and in vitro studies. We don't know whether or not this actually happens in humans, though. And certainly, drinking red wine, you will have resveratrol in it. You will get some health benefits from it, but it's unlikely you're going to have sufficient amounts of the resveratrol to have this anti-aging effect. And the problem with wine is because of the basically alcohol content, you're more likely to shorten your life by drinking 2 bottles of wine a day in order to get the resveratrol you need from it. So resveratrol does have this anti-aging potential. You will get some benefits from having a little wine in your diet, but the alcohol you got to watch out for. So we'll have to wait and see whether or not supplementing with resveratrol will have any benefit for humans to extend maximum lifespan. For now, we don't really know. I would say a caloric restricted diet seems to have benefits. Intermittent fasting might have the same benefits as well. Those are a little bit better established, but resveratrol, some interesting research exists, but I don't know how to translate that to humans. The other property that these stilbenoids have is they have phytoestrogenic effects. And so they can fit into, remember when I showed you some of the slides on soy isoflavonoids and how they have an antioxidant or a phytoestrogen effect? Resveratrol also has this effect. So red wine and some of these fruits and vegetables that contain resveratrol actually will have some phytoestrogenic effects associated with that. What's interesting is there is a herbal supplement that one of the nutraceutical companies makes. They kind of have the exclusive rights to this product, and it's basically a stilbenoid extract from some type of rhubarb. I can't remember what type of rhubarb it is, the root. And it's basically been shown in a number of clinical trials to have benefits for reducing menopausal hot flashes and some of the other symptoms associated with estrogen deficiency when women go through menopause. And it's neat. The company actually offers a money back guarantee if it doesn't work, which I've never heard of any supplement company offering that. So I've used it in clinic a few times. I'm not going to mention any names. It seems to work maybe for some people, but not for other people. The company says it will probably only work on 70% of people. I think that might even be a little bit high, but it is interesting that these compounds, they have a lot of research to support them. They do appear in research studies to lower a lot of menopausal symptoms. And maybe they have other benefits like antioxidants and anti-aging effects that we don't know about yet. So it's interesting. It's still probably we need more research, but it's still kind of interesting. So I think the take-home message for like exam purposes and just to know, stilbenoids are primarily found in red wine. That's going to be the main source. In berries to some degree as well. It has antioxidant. It may have some anti-aging effects. Also, the phytoestrogenic effects is important. I also want you to know that resveratrol is kind of the archetypal one that everyone knows about, and just know resveratrol is a stilbenoid, okay? Now that we've done the stilbenoids, now we want to talk about the flavonoids. There are several different classes of flavonoids that we're going to go into. And if you remember, the flavonoids are shown on the left. When it comes to flavonoids, there are several different classes of flavonoids. There are flavones, isoflavones, flavonols, flavanols, and anthocyanidins. Now, this little summary chart here that I've shown, the difference between these different things, the differences between all the different flavonoids is based on their chemical structure. And so if you look at this, the numbering on here, if you have a ketone group, which is a double bond to an O, on the 4 position, then that's a flavone. So ketone, flavone. If you have that second ring structure, instead of being at the 2 position, it's at the 3 position. That's called the iso position in chemistry terms. That's called an isoflavone. Now, if you have a ketone at the 4 position and an alcohol at the 3 position, then you get a flavonol. So you got the flavone with the OLS, refers to the alcohol component. That's a ketone and an alcohol, gives you the flavonols. And then finally, if you have no ketone at the 4 position, so kind of like I would remember it by saying it's like a ketone, meaning no ketone, and then you've got the alcohol at the 3 position, then you get the flavanol. It's not a true flavonoid, but it is still related to it. And then finally, you get the anthocyanidins, which are not really a true flavonoid, and it has a slightly different charge set up there with the double bonds are kind of conjugated along the central ring there as well. So that's a quick little summary, because it can be a bit of a mouthful for each of these. Now, when you have these different flavonoids and flavanols and everything else, by adding and removing oxygens in a ketone or an alcohol, like, it'll change the way they interact to some degree. They're different molecules. They're still polyphenols. They're still going to have antioxidant effects. Some of them are going to have slightly different three-dimensional conformation. They're going to fit into different enzymes. They're going to have some other different properties. They might be able to interact with some other compounds as well. So we'll go through that. In general, I think these are all just good to have in your diet. And consuming a diet rich in lots of different flavonoids is going to be good for you. Someone asked me, does caloric restriction and fasting have similar effects on life extension? I don't know. I'm not an expert on that, but there definitely is some research on that, and I'd have to go and look at it in detail. Someone asked, is the effect of resveratrol on the aging related to telomeres? Don't know. I don't know how it works. It turns on some receptors. It may indirectly affect telomeres. I think telomeres are usually a marker of the age of the cell, not necessarily. I don't know if they target them or not, though. So my answer is I don't know. So if you look at the different flavonoid classes that have discussed anthocyanins, flavonol's, I think I must have taken this from a study somewhere. It's in a slightly different order than what I'm showing you. You go through all these different things. Look at the common plant sources: blueberries, red wine, strawberries, teas, chocolate. Basically, if you eat more of the foods on the right-hand side, it's just going to be good for you, because of all these different compounds and flavonoids. So when you eat a diet that's rich in polyphenols, it would be eating a lot of these fruits and vegetables, and then throw some spices and herbs in there as well, and you're doing pretty good. This was a research study I looked at for a flavonoid-rich diet. And basically, they had 1,000 women over the age of 75, and they looked at what their 5-year risk of dying is in that 5-year period, which is around 12%. And what they found is that if the women ate a diet that was rich in flavonoids, it reduced all causes of death, cancer, heart attack, etc., had about a 63% risk reduction, which is pretty significant. So for this group of women, if their risk was about 12%, then it would basically reduce it by 7.6%. So what that means is when you have switched these women to a flavonoid-rich diet, about 1 in 23 women, life would be saved by consuming more of these types of fruits and vegetables. And that's better than most drugs, to be honest with you. Cholesterol medication will give you about a 30% reduction, give or take 5. Blood pressure, maybe about 20%. Aspirin, about, I think it's like 15%. So that's pretty good. The other benefit of this is it tends to be, it tastes good, and there's no side effects really, or minimal side effects, except for maybe the cost involved. Christy Lynn commented on the resveratrol. Resveratrol produces SIRT1 in the body, which is believed to extend lifespan by maintaining energy and nutrient homeostasis, which is linked with the anti-aging role in the body's metabolism. That's a better answer than I can give, so thank you for that. I read these things and I forget them, all the details at some point. And this whole anti-aging, cancer, everything else, you can become an expert on this stuff, and it's very, very. It'll take you days to go through all the research on it. Here's another study that showed the health benefits of drinking green tea. Now, green tea is good for you, but appreciate this study looked at men who drank more than 5 cups of green tea a day. And for this particular group, there is basically a 13% reduction drinking 5 cups of green tea or more per day. That's a lot of green tea. Like, I don't get anywhere near that. And for this, it basically means if you're drinking 5 cups of green tea a day, it'll lower your relative risk of dying by about 15%. It's not that much. So green tea is good for you, but drinking it alone is not going to do any miracles for you. Because in this case, this study, I think you need to have about 60 people drinking the tea. Now, this is probably a younger study. I don't remember all the details. About 60 people would have to drink that much tea to have one person benefit. So, again, here's an example of one specific food that's rich in polyphenols. And green tea it's got a lot of great things about it, but I'd rather have green tea and blueberries and coffee and red wine, one of many different fruits. And I think the results would be even less uh, significant if you just took the active ingredient like the ECGC and took it as a supplement. I bet you the number needed to treat would be even lower than that. So that how many people you'd have to give it to for people to benefit. So all these things have benefit, but appreciate when you get 10% here, 5% there, 6% there, they don't seem that much alone, but have the green tea and reduce your red meat and increase your orange and drink more coffee, you're going to have some good effects. So we'll start off with the polyphenols. Someone's asking, does it mean matcha is better because it's more concentrated green tea? I don't think matcha is that much better than normal green tea. Like, it probably has more of the antioxidants, stuff like that. But again, you're taking more of the same thing. And so I think matcha is good for you, for sure. But I haven't done I haven't looked at the research comparing drinking green tea versus drinking matcha for lowering the risk for heart disease and cancer. I think it's a lot more expensive. If you like drinking it, drink it. I think it's good for you. Um, but I don't know if it's any better for you than drinking normal green tea. Significantly, it might be, but again, you have to drink a lot of green tea to get that much of a benefit from it. So, but I'm drinking green tea right now, and I may have 2 cups of green tea a day, which is not in that 5 cups or above, but I'm doing other things in addition. So I'm having different phytochemicals from a variety of different things, and I'm hopeful that that's based on what I've looked at for the research. That's probably a better way to do it than just trying to overdo it with one thing. So flavones. So as I mentioned before, the flavones have this ketone at the 4 position. 2 really important things that I can think of are apigenin and luteolin. These are found in lots of different vegetables and in herbs as well. Celery has a lot of health benefits associated with it. Some of them are related to the flavonoids. Some of them are going to be related to other compounds, including phthalides, I suspect. Apigenin it's a very common it's a very, very common flavone, and other places where you can find it, for example, is chamomile tea. So when you drink chamomile tea, it's like you're getting a supplement containing apigenin because you have a lot of these different flavonoids in chamomile, including quercetin and some other ones. And a lot of these flavonoids have been shown to have obviously antioxidant and anti-inflammatory effects, but it appears that maybe some of the health benefits associated with chamomile tea can be can help with cramping pains in the digestive tract. Some of it's related to the essential oils, but some of it may be related to these flavones as well. Furthermore, chamomile has a very gentle calming effect, and it has a bit of an anxiolytic effect, so it helps to reduce anxiety. And it's certainly research has shown that in large clinical trials. It's gentle. It's nowhere near as potent as conventional drugs, but often you don't want something too potent. So a little cup of chamomile tea, most people, it doesn't make them sleepy. It can kind of calm them down and make them helps them fall asleep. But if you drink it during the day, you're not going to suddenly fall asleep. But it might help calm you down and make you a little less anxious. And so it may be partially related to these compounds like the apigenin. Some of the anti-cancer effects, for example, chamomile tea has been shown, at least in women, to have some beneficial effects of lowering certain types of cancer, We know that celery lowers both cholesterol and blood pressure. There appears to be some anti-diabetic effects associated with chamomile tea. We know that it can help with blood sugar levels, so this is the flavonoid content in there, which is good. So lots of really positive things associated with these flavones. Some of these benefits might be seen in some of the other flavonoids as well, but we know that this exists for these guys. When you look at luteolin, for example, it basically has a number of anti-cancer effects, and I don't really know enough about the biochemistry of this, even though my background's biochemistry. This is all stuff that I don't really know a whole lot about, all these different receptors and how they interact. I think you could do a PhD just on these pathways, but you can appreciate that the luteolin appears to work by 1, 2, 3, 4, 5 different mechanisms. So obviously it has antioxidant effects, helps protect against DNA damage, has some effects on various receptors like the P50, P53 receptors, seems to have some effect on PKC, which is one of these markers involved with cancer. So you don't need to know this slide. I'm only showing it to you just so you can appreciate it doesn't have a specific action on cancer. It just seems to have a whole bunch of actions. Oranges and grapefruits also have different flavones in there. So hesperidin and naringin are both found in citrus. You get one more in oranges and the other one more in grapefruit. Oranges and grapefruits have other benefits to it, but again, I'm just looking at going, how can I get a little bit of all these different various polyphenols? And so having a little orange, a little grapefruit, some celery, some chamomile tea, a little green tea, I think it's all good to do. Now, the next group we'll talk about are the flavonols. So flavonols means that you basically have the ketone at the 4 position, and you also have an alcohol or OH group at the 3 position. So ketone at 4, alcohol at 3. And I don't know how much this changes its properties. It's still going to have antioxidant, anti-inflammatory, anti-cancer effects. Now, I know in particular quercetin is probably the most well-known flavanol. It's one of the few flavonoids that you can get as a supplement on its own. And I do use it as a supplement with vitamin C for people with allergies. It does have an antihistamine effect. And in your diet, you will get in a number of different fruits and vegetables. Onions are rich in it. And if you look at the onion on the left-hand side, the photograph I took there, you can actually, I'll admit, I slightly popped the yellows in it in Photoshop just to exaggerate it a bit. But that yellow color that's seen there, it is there, and it's caused by the presence of these flavonols, in particular quercetin. So in Latin, flavus means yellow, and so that's why the term flavonoids exists, is because these were some of the first flavonoids that were found, like quercetin, because it's so widely spread, and it has that yellow color to it. I would imagine that the color of it's associated with the type of visible light that it reflects. And because of the conjugated double bonds that you see, the number of conjugated bonds that a molecule has will affect the light that it reflects. And whether that's in the visible range is dependent on how many of these guys you have together. So when you look at going back to the terpenoids, for example, monoterpenoids and sesquiterpenoids, there's no color because they don't have any, they may have like a phenolic ring and that's it, some of them. So that's like 3 double bonds, but that basically will affect UV light, won't affect the visible light. When you start getting into longer ones, like when you get the tetraterpenoids and the carotenoids, where there's long chains of these conjugated double bonds, or you get in some of these flavonoids where you have the double bonds are connected through the ring structures, and the bridge also has ketones and double bonds. They will reflect light and give certain wavelengths of light. So you tend to get colors and pigments associated with flavonoids, ranging from yellow, orange, blue, purple, all in the visible range. So flavus is yellow, and so probably some of the first ones researched were quercetin, and it's found in onions, citrus, most leafy vegetables, and tea. So you'll find this is probably one of the most prevalent ones. I use it as a supplement as an antihistamine, would be the main thing. It also has been shown to have benefits for lowering blood pressure as well that I've read. So I think flavonoids in general may help with blood pressure. Now, just as an aside, many different flavonoids can exist as glycosides. And what that means is you can have a sugar attached to it. So there are many, many different glycosides of quercetin that exist. Rutin is an example of one where there's a couple sugar molecules attached to it. When you hydrolyze those, you release the quercetin. I've read studies showing that rutin, which I would say functionally it's going to have the same active sort of molecule, the quercetin, once the sugars are released, but this may have a better therapeutic effect on things like inflammatory bowel disease than quercetin does, even though it's the same aglycone molecule, the same quercetin molecule. It might be the sugar helps deliver it to the bowels before it gets activated. So most of these flavonoids, just so you know, most phenolic compounds in general, they are metabolized by gut bacteria, and they can have a significant effect on them, and that can act as a prebiotic for some of the gut bacteria. They can also act as have different sort of effects. So when the gut bacteria work on various phenolic compounds in the gut, you will have them activated and change structurally as well, or inactivated in some cases. So the next ones are the isoflavones. These are structurally similar to the flavones. The difference here is you still have the ketone at the 4 position, but the second ring has moved from this number 2 position to the number 3 position. The two classic isoflavonoids are genistein and didazyne. Those two are found in soy, and they may exist as a glycoside in soy, but these compounds are also found in other legumes. So, for example, red clover is a legume, licorice is a legume. They too have different types of isoflavonoids. Now, like all the antioxidants we've talked about, they're going to have some, or all the flavonoids we've talked about, they're going to have antioxidant and probably some anti-cancer effects. But in particular, these compounds, because of their three-dimensional orientation in the estrogen receptor, they're going to act as a modulator to estrogen receptors. And so they have a phytoestrogenic effect. Now, some studies show significant benefit for soy or red clover extracts, which are basically like the soy isoflavonoids, for menopausal hot flashes. Some studies have shown no benefit. And there's a number of reasons why that could be. But one thing that we kind of have learned that your gut flora will impact whether or not you activate the soy isoflavonoids or not. And so I've used both soy and red clover extracts in women. Some women has a significant effect on their menopausal hot flashes. It may, if their hot flashes are like a 6 or 7 out of 10, it might drop it down to a 4 out of 10 or a 3 out of 10. Other women it will have no effect on. So my opinion on it is things like red clover extract and soy, they might be worth trying with some of your patients. They are not as potent as synthetic estrogens or even naturally occurring estrogens, like hormone replacement therapy definitely works better. These tend to be a lot more gentle. They may reduce the risk for osteoporosis. They may reduce the risk of things like depression. We also know that these isoflavonoids have antioxidant effects. They probably have cholesterol lowering effects and also blood pressure lowering effects, whether it's related to these compounds or other compounds in the soy. So a diet that contains soy does help to lower cholesterol and blood pressure. I've read one study that shows drinking a liter of soy milk a day can lower blood pressure as much as 15 points. It's a lot of soy milk. I don't drink, it'd be hard to drink that much, but I don't know if it's related to the protein composition or related to the isoflavonoids or a combination of both, but there's potential for these things to have some therapeutic effects. The take-home message here is the isoflavonoids have phytoestrogenic effects in addition to the other properties you see with the other flavonoids. And I think it's important that you know that soy is some of the main sources. Red clover is also source of licorice. And it's worth knowing that genistein and didesign are two examples of that. Okay. Um, I don't know how important it is for you to know this, but in this is kind of a compound that's unique to licorice. Appreciate that when you look at a lot of the indications for licorice in Chinese medicine, it has so many different indications, including it's used for a lot of female complaints. It's been used for PCOS. It's been used for what do you call that? Peony is a herb that's combined with licorice for a number of different female complaints. It slipped my mind right now. It'll pop into my head later on. But anyways, so licorice, in addition to having some effects on various hormones like aldosterone in the body, works on the digestive tract. It also appears to have some phytoestrogenic effects, and this is probably one of the compounds that's responsible for that. Yusuf is saying you have quercetin under both flavanols and flavones. Let's clarify that. So I'll take it out of here. Quercetin is a flavone, but it's a more specific flavonol. And the reason why is some people will classify quercetin as a flavone because they don't go into that distinction between it and the flavonols. So it gets some books, depending on how they classify stuff, they don't go to that next level deeper. Okay, so it is a flavone. It's just a subspecies of flavone where you have flavonols, like a double one. But you may see it under the flavones as well as the flavonols. Both would be accurate, I guess, to some degree, but the flavonol is more accurate. Someone's asking, why does sage work for menopausal hot flashes? I don't know, and I do recommend sage, like garden sage, for women with menopausal hot flashes, and I have no idea what the mechanism is. So the next group we'll talk about are the flavanols. Flavanols, they're not really a true flavonoid. Green tea contains a lot of things called catechins. So both green tea and chocolate contain catechins like catechin and epicatechin. I think one of the reasons why plants produce these is because they can absorb UV radiation and help protect the tea plants from getting a sunburn. And so if you know a lot of tea grows at a higher altitude where the UV radiation will be stronger. And so this may be why the plants produce it. It's a good antioxidant and it helps absorb the UV radiation. Also, the research shows that these guys have antioxidant, anti-cancer effects as well. Both tea and chocolate have a lot of health benefits that are related to the catechins. Now, in addition to that, if you ever wonder, that's what chocolate looks like. It's beautiful looking fruit with the beans are inside that. Now, with green tea, there is a compound called epigallocatechin gallate. It's a bit of a mouthful, EGCG. And this is something that a lot of research has gone into this particular compound. And what it basically is you have the epigallocatechin. So it's a type of catechin molecule. The names will change based on how many OH groups you have on the phenolic ring structure. So you've got a catechin that's attached to a gallic acid molecule or gallate molecule. And so this EGCG molecule has a significant amount of research around it for all sorts of different things. It's a great antioxidant. It appears like it might have some anti-cancer effects, although there's some debate on that. There's also research from a supplement standpoint that it could help with chronic fatigue syndrome, endometriosis, and HIV. So there's specific studies for that. And you're going to find this exclusively in the white and green tea. Now, it's worth mentioning that although chocolate has catechins, and the catechins are found in both in tea and green tea, black tea, and also in chocolate, you will only find the EGCG in green tea, maybe a little bit in black tea, but mostly in the green and white teas. But none of that will be found in chocolates. So you can't really take the health benefits of green tea and apply it all to chocolate. But they both have either one of those. I like eating chocolate because I like chocolate, but also it has good benefits for cardiovascular disease. A lot of this is hard to talk about every single action it has, but anything that's an antioxidant will probably have beneficial effects on the cardiovascular system. I even think that chocolate will lower cholesterol. It looks like there's research to support that. So will green tea. So it may be related to these compounds as well. A couple different studies. Won't go into those right now. Now, the final group that we'll talk about are the anthocyanidins. These are kind of related to the flavanols. The main difference is you get this positive charge on the oxygen group in the middle here, and a couple other little double bonds there. Because of these guys here, these double bonds in here, you get this conjugated system of double bonds that will reflect not UV light, but violet light. So this is where you get a lot of the purple colors and things like that. Purple and blue that you'll get in the berries are associated with these anthocyanidins. Now, what's interesting about these anthocyanidins, they're not technically a true flavonoid, but they are a subclass of the flavanols. And they've got that positive charge. Now, you may have heard of anthocyanidins and anthocyanins. Anthocyanins are the anthocyanidins, but with sugars attached to it. So they're going to be the glycosides. So anthocyanidins are the aglycone portion of the anthocyanins. Now you'll find a lot of these compounds in anything that's kind of blue, purple, sometimes red, but mostly in blue and purple things, you're going to get it. So the berries, blueberry, blackberries, wine will have it in it, in like the grapes, elderberries. Also, if you're buying cabbage, why not buy the red cabbage? Because it'll have the anthocyanins and anthocyanins in it, giving you extra benefits in addition to the good stuff that's in cabbage. And also cherries. So again, antioxidant, anti-cancer. These guys also appear to have an anti-adherence effect. You may find this with some of the other phenolics, but a lot of the research has been done with these guys. So they can help prevent the binding of bacteria and viruses to your mucous membranes. So to give you two examples of that, for example, elderberry contains certain ones that appear to, they may modulate the immune system, and they also appear to prevent the adherence of influenza virus and other cold viruses to the mucous membranes. So they kind of decrease the ability of the viruses to invade the host cells, and research shows that they basically lower the risk of getting the flu and also decrease the severity of symptoms. Red cabbage, I don't think there's any study showing benefits for colds and flus, but it's pretty and it tastes good. And the other one would be, I don't have a picture of it here, cranberry. Cranberry juice helps prevent women from getting, or helps prevent and treat urinary tract infections. And there are a couple different things that could do that. Some of the carbohydrates in it may have an anti-adherence effect, but in addition, some of the anthocyanidins might also have this anti-adherence effect as well. Now, one of the things that's kind of unique to the anthocyanidins is because they have that positive charge on the oxygen and the placement of those double bonds, they can easily undergo a certain type of reaction that will form polymers. So there are things called oligomeric proanthocyanidins, or OPCs, that are basically these polymers of these anthocyanidins that change the chemistry and make them act as important astringent compounds. And there's research that have been done on these guys as well. So usually when it comes to berries and grapes and stuff like that, they will also contain some of these OPCs as well. Now, something that's kind of interesting about these is because of the conjugated double bonds on these anthocyanidins, in an acidic environment, what ends up happening is it changes the chemical structure in the double bonds so that it no longer basically reflects the light in the purple and blue spectrum. It actually changes it to becoming more red. So if you take cranberry juice and you neutralize it, because cranberry juice tends to be a little bit more acidic, if you alkalinize it using baking soda, it'll actually change color and become more purple or blue in color. Because basically blueberries and cranberries have very similar phytochemicals in it. One just happens to be more acidic than the other one. And so what's neat is a lot of litmus papers, for example, use anthocyanidins. So here's basically, I took this from Wikipedia, but this is basically a nice picture of purple cabbage. And depending on the acidity of it, more acidic is on the left and more alkaline is on the right. And so the solution will change colors based on how acidic it is, which is kind of neat. And that's related to those double bond structures there. Some other sources, blood oranges and apples, the red colors that you find in there are going to be related to these anthocyanins. So normal oranges probably don't have significant amounts of these anthocyanins, but they bred them in the blood oranges that have these compounds as well. So it's like a little added bonus, just like you see with the red cabbage. Apples have a lot of health benefits associated with it. It contains the anthocyanins in the peel. That's where all the good stuff is, in addition to the fiber. It also has compounds like ursolic acid. So apples, there are multiple compounds in it that have anti-cancer and antioxidant effects in it. And as I mentioned before, some of the anti-adherence effects of cranberry and elderberries are related to these compounds. And what they do is they bind to the adhesins, which are little suction cups on the feet of viruses and bacteria that allow the bacteria and viruses to stick to our mucosa cells. And if you fill all those little binding sites up, it makes it more difficult for these bacteria to attach and then invade into our cells. So the final thing we'll talk about, which is kind of review, or at least today, which is kind of review, are tannins. Now, plant tannins, I've already mentioned this already, these are phenolic compounds that what will happen is when you consume them or you apply them to your skin, they will interact with proteins and they bind and form cross-linking that'll precipitate certain proteins out of solution. Now, on your skin, what will happen is if you have an open wound because let's say you've cut yourself shaving and you apply tannins topically, what will happen is the tannins will react with the exposed tissues and the amino acids and proteins there and form a cross-linking and basically have an astringent effect. They'll basically tan that. And so tannins, the primary medicinal action associated with tannins is an astringency. So they're designed to interact with nitrogen-containing substances, and those are going to be found in your proteins in your skin. They will also interact with other compounds as well. So if you have a lot of minerals or even certain compounds called alkaloids that are rich in nitrogens, tannins will kind of neutralize or inhibit those guys as well by binding them up. Now, when it comes to tannins, there are two main types of tannins that we'll talk about: hydrolyzable tannins and condensed tannins. We'll get back to those in a second. When it comes to the effects on the body, if you bite into a green banana, you'll notice that your mouth becomes sort of puckered. It'll have that astringent effect. Or if you drink a lot of oaky red wine, you'll find that your mouth will start to pucker up. A lot of red wine on an empty stomach, for example, like a Grand Reserve Rioja wine from Spain, it's been aged in an oak barrel. So you have a lot of astringency from both the berries themselves. The grapes have hydrolyzable tannins, and then the oak has, the berries have condensed tannins, and the oak has hydrolyzable tannins. It's very, very astringent. And that's one of the reasons why you're supposed to drink really oaky, astringent red wines with, let's say, steak. Because rather than the tannins interacting with your cells, it interacts with the steak and sort of binds up the proteins in the steak and just complements it. If you eat a lot of, or if you drink a lot of oaky red wine on an empty stomach, you'll probably notice you'll get gut rot from it. You'll start noticing the tannins will start to bind up the various proteins in your gut, and you might sort of have a little bit of stomach discomfort, a little bit of cramping pains if you overdid it. And that's not just from the alcohol, that's actually from the tannins. So what tannins do is when you have an exposed tissue, it tends to make it leathery. And so basically plant tannins were used to tan animal hide. So if you take an animal's skin, it's very, very thin and delicate. Once you apply tannins to it, and you could be doing tannins in the form of like oak bark, or it could be some kind of chemical astringent compound, it thickens up the leather, or thickens up the skin to produce leather. And so appreciate, if you had an open wound and you're bleeding, you apply tannins to it, it'll make that wound thicker, more resilient, stop the bleeding. Internally, it'll do the same thing, but it could also have a negative effect on nutrient absorption. So the main actions with the tannins is going to be an astringent action. It can also inactivate certain bacteria or bacterial toxins. So if a toxin like that E. coli produce is protein based, it could actually go and neutralize some of these proteins. And that's one of the reasons why tannins often will have an anti-diarrheal effect. So it'll inhibit diarrhea because it sort of tans the bowel walls as well as inactivate some of the enterotoxins produced by these bacteria. Also, with open wounds, whether it's internal from an ulcer or topically from a scratch or a scrape or something, it'll help to arrest bleeding, which is what hemostatic means. And then finally, because these tannins are rich in phenolic compounds, they'll have an antioxidant effect as well. So the things to be concerned about is tannins will affect nutrient absorption. And so if you alter the bowel walls and make it more leathery-like, obviously it's going to affect some of these protein-based transporters that are involved with absorbing certain nutrients or releasing stomach acid, because it does have, a lot of these tannins have antacid effects as well. Also, they can directly bind to various minerals and prevent their absorption. So there's another way that it can have a negative effect. And finally, high amounts of tannins could be toxic to both the bowels, liver, and the kidneys. Usually in herbal medicine, you're not taking tannins in high amounts for long periods of time. You might take it in a relatively high amount to treat something like diarrhea or a stomach ulcer, but it's usually only going to be for a few days or a week or something like that. You look at certain animals like squirrels that eat a lot of acorns, they have their own unique enzymes to deal with all these tannins, because certainly we wouldn't be able to eat acorns on a regular basis. It just would be toxic to us. So the two types of tannins we'll talk about are hydrolyzable tannins, and these are tannins that are found primarily in witch hazel, also various species of oak. So Quercus species, SPP, that I've written down there, that's that could be Quercus alba, would be white oak. Red oak is Quercus rubra. So lots of different species of oak can be used in herbal medicine, or used to store wine or whiskey or whatever it is in. Pomegranates have them in the rind as well. Tea has a number of types of hydrolyzable tannins. And so what this is you basically have the gallic acid and ellagic acid is your main phenolic compound that has an astringent effect. But when you add a whole bunch of sugars to it, you'll get glycosides of this. And there's a couple examples like tannic acid or punicalin are found in various things like tea or pomegranate and are responsible for these astringent effects. So this is the A glycone of the hydrolyzable tannin. So oak bark, in particular, the little these little balls on the side of trees are often referred to as galls. Those galls tend to be higher in tannins. Uh, Pomegranate is high in ellagic acid, so add a bunch of sugars on those OH groups and you'll have some kind of hydrolyzable tannin. The other type of tannin, rather than using gallic acid or ellagic acid as your main astringent compound, condensed tannins or non-hydrolyzable tannins use basically the anthocyanins that we talked about earlier. The oligomeric proanthocyanins are the main ones. And so these condensed tannins are found in lots of different fruits and vegetables, including blueberries, cranberries, grapes, elderberry. So when you next time you eat some blueberries, you'll notice there is a very gentle astringency associated with consuming berries. You'll get it with a lot of different berries or even wine. So at the wine, most red wine, even if it's not been stored in a oak barrel, there'll be some astringency to it. When you have the red wine, then that's been like I mentioned, the Grand Reserves have been stored in oak barrels. They'll have both the hydrolyzable tannins from the oak and the condensed tannins from the grapes themselves that'll have that astringent effect. So it's very, very astringent. But even uh, red wine that's not stored in oak barrels will have some astringency to it. There's just a couple different versions of your hydrolyzable and condensed tannins. In general, I find condensed tannins tend to be a lot more gentle than the hydrolyzable tannins, but they can still be pretty potent. So that's probably a good spot to stop. Next time we'll finish off the phenolics. Let's see. I might leave the alkaloids for the final, just so that we're not rushing through that stuff. I'm gonna have to decide if I'm gonna cover all the phenolic stuff or not today, and I'll let you know. So we might finish the phytochemicals before the midterm, or we might save some for after the midterm as well. It'll just make, I don't know, do you guys want, I don't think I can easily cover it all before the midterm. Okay. Apparently the sound cut out for a second. Okay. Do you guys have any other questions? I got a couple here I'll go through. How do you know whether it's worth it in a condition like ulcers in the gut, if this will help close the ulcer or if it stops nutrient absorption? Um, so if you were using tannins for a stomach ulcer, what you need to do, the most important thing is to heal the ulcer up. That would be the primary thing you need to do. So using something like an astringent herb for a few days or a week to heal the ulcer is much is you're not going to worry about nutrient absorption for a few days or a week because you can live without food for a few weeks and you'll be fine. So short term, you're not going to worry too much about nutrient absorption. Long term, you would worry about that. Short term, it's more important to stop bleeding and heal an ulcer than it is to worry about if you're getting enough iron because you've got iron stores and nutrient stores in your body. So that was the one thing. So quick question. What do you guys think? Do you guys want me to try to get all the phytochemistry stuff done before the midterm's done? It would make it a little bit rushed, or you guys would have to watch a video outside the class time in order to make sure we covered all the material. Or do you want me to just cover it after the midterm? I can do either one. I don't think it makes a big difference. Any thoughts? Okay, so far, okay, so right now I've had 1, 2, 3, 4, 5 people, 6 people all say after the midterm, 0 people say before the midterm. Okay, so I will do it after the midterm then. That'll make it easier. The midterm will be easier. That's 7th person. So everyone's saying after the midterm. So I guess we've got enough material. We don't want to overwhelm you. So next week we'll finish this stuff and we'll end at the alkaloids. And we'll do the alkaloids after the midterm, and then we will do an exam review then. Okay? Do you guys have any? Let me just double check. How many more lectures do we have? 1, 2. Just one more. Okay. If we got just one more, then let's leave it off and we'll do it afterwards. So if you guys have any questions, let me know. Send me an email or post it on Moodle and then send me an email. Let me know that you posted it. Okay? We'll see you next week. We'll do some exam review next week too then. Okay? Hope you guys have a great week. Talk to you soon. Okay, bye for now.